So when it comes to wastewater treatment, it has never been easy. It has always been a challenge, but today it's even more, let's say, exciting than ever, or challenging, depends how you look at it, because the core business of wastewater treatment is safeguarding effluent quality, have a very good and have a very good plant efficiency. So treat wastewater. And now we have this third juggling ball, let's say, the emissions. And it's quite complex because these three are not always good friends, and it's very hard to have the perfect plants. By the way, this image was generated using AI. It's a photo juggling balls literally at the wastewater treatment plant. So this is the digital age. So many utilities want to reduce their carbon footprints, even though at the national level there is no regulation. In many instances, many utilities want to reduce their emissions, because we are working in the environmental industry. And then laughing gas or nitrous oxide is likely the most efficient way to do so, because it has a very big contribution in many utilities to the global footprint. But we are of the opinion, and that's why we have been developing all of these tools, that mitigation should be practical. It should be done at a reasonable pace. So we cannot really wait 20 years for that. And also it should not compromise the other goals you have as a utility. That is very important to take into account. So nitrous oxide has specific challenges, and I'm now going to hand over the microphone to my colleague Peter. He will be zooming in on those.
Yes, hello everyone. Indeed, so let's now go a little bit more into the details on the challenges when it comes to N2O for utilities. Usually utilities have two main goals when it comes to N2O. At first instance, they want to assess their emissions. So what's their baseline of their emissions? And then as a second goal, they want to really reduce their emissions of their current infrastructure and new designs or renovations, etc. So now, based on the discussions we had with a lot of our customers, what are now the main challenges when it comes to the assessment? It's, for example, first question, measurements. How will we measure? Liquid phase, gas phase? Where will we measure in the reactor? How long will we measure? These are typical questions that come up. And then, like Wim already showed, the dynamics in a full scale, a lot of things are changing at the same time, which makes it very complex. And then when you measure, you have a lot of data from the liquid sensors, but also liquid phase sensors, but also other sensors. And this interpretation is very complex. Giacomo will show that in the next slide. And then on-site monitoring is also very costly and takes long. Cabling, electricity can be very expensive. Then visualizing and quantify really your yearly emissions based on the measurements is also a very difficult task. And then when it comes to maintaining your sensors, etc., it's also a very tedious job, and plant staff is often already quite occupied. So now we will talk about the challenges in mitigation. So Wim already talked about the three balls. So effluent quality indeed also needs equal attention. If you reduce emissions, you want to preserve your effluent quality. And then, if you apply a certain mitigation strategy, it's sometimes hard to confidently report on your reduction because of all these dynamics we have shown. Is it really a reduction that we see here? And then if you want to come up with a mitigation plan, you want to understand the root causes, but measurements don't always show you these root causes, which makes it difficult to come up with a good mitigation plan. And then, if you apply mitigation strategies, do you still need to continuously on-site monitor your emissions? And how will you do that? Then multiple scenarios are possible to test mitigation strategies, but how will you test them in practice? What if testing is not always so easy on a full-scale installation? And indeed, then we have new designs or renovations. How will you design for a new wastewater treatment plant for minimal N2O production?